This is the lower element. And then there's one up here too. And it'll look like this. If it's an electric one, it'll look like that. This thing goes underneath, and I've got my ground screw in the way, so I can't put it back. And this thing covers the, it just goes over the, goes in there like that, I think, or upside down. But you can tell right away.
Yeah.
If it's a gas heater, instead of having the electric hookup, however they've got it configured, it'll have the gas outlet over here, you know.
Yeah.
And it'll be a pipe. And it won't have the second door.
Oh, okay.
I don't know that it even has the first one, but I think it does. So or maybe it's down here so you can get to the, yeah, it is down here. It's a long one, so you can get to the pilot.
Oh, okay, yeah.
Yeah, and the newer ones I think are electronic pilot, but they still have that door so that you can adjust the pilot. You know, you can adjust a pilot flame, how big it is, and that has to do with thermocouple on something like a furnace.
This is your ground?
Yeah. Yeah.
And that goes for your hot water upstairs?
This is floor.
Yeah, but I mean this one?
Well, this is supply.
Oh, okay.
And this is a pressure tank so that it absorbs any pressure differential up to a certain point. This is how, I'm not going to do it, but this is how I bleed the air.
Oh, okay.
Here, and this is an air bleed here too. And this tells me the temperature that I'm sending out my water. Well, actually, this tells me the temperature that the water is in the tank. At first, it won't say anything because it'll take a while for the, for the water to heat up and get up there. Yeah, what the heck is this thing? This is some kind of a safety on and off. Oh, this is a pressure regulator. You can see the pressure here. And you can adjust it,
Oh, okay.
And this is a check valve in here so it can't go the other way. Once this gets hot, it'll put more pressure on this side than on this side, or conceivably it could. And so there's a check valve in here, can't go the other way. And then out there is you see we split. We've got 4 instead of 2 tubes, we now have 4. We come out with 2 and we split into 4 because it's the same zone because we're heating everything at the same temperature, but I've split it in 2 so I could have my 400-foot coils on each side. Now, if you wanted to, you could alter this and make it into 2 zones so that you're heating one half of the basement at one temperature and the other half at another temperature. Or if you wanted the bedroom. Now I forget how I configured it, and I didn't want to be 2 zones. But let's say we were going to do this upstairs, and you wanted the main living room to be warmer than the other one. Then you could have it set on a separate zone. You can put your temperature regulators. Let's see, where are my tempering valves? Oh, this is the tempering valve. This makes it hotter or colder depending on what you want to do. So you can see what you're going out at and what you're returning at. And so you can put another tempering valve at the head of your other loop. And you can run them at different temperature,
Yeah.
one room warmer than the other. Something like that.
So So this is like a thermostat that goes inside the piping, like.
It's a thermometer. It's not a thermostat
Oh, okay.
as such. Now, if you wanted to have a thermostat, you'd have to hook it to the pump because the thing's only working when the pump works.
Yeah, and this has like the
You hear
probe.
it?
Oh yeah, the pump. Yeah. So that's just cold water flowing.
It's just
Yeah.
it's what's in here.
Yeah.
You know, I don't really like to let equipment sit idle. You know, it's not. I'd rather be running it to make sure everything works. But
Yeah.
and I had it, you know, for a while on a timer.
Oh, okay, cool.
So yeah,
The pump.
exactly. So that you know, it's not running 24/7. Now, the other thing that you can do on a 24/7, which is what I did in the beginning, is set your tempering valve relatively cool, you know, 70 degrees or something, and start it, you know, in late September, and just let it run 24/7. And then when the water's coming back, it's still pretty warm, and the water's coming back at, you know, 65 or something like that. This thing doesn't fire up very often because the water's at 70 degrees, and if you're only trying to keep it to 110 or something like that, 120, it's not losing much energy in the floor because everything's already warm. You know, it's
Yeah, it holds it pretty well.
yeah, it's running at a pretty under a light load. Let's put it that way. It's just cruising. And then if once it gets cold, it has to work a little harder. It has to put more energy into it to maintain.
And this.
Well, that's just if I want to
Oh, okay.
drain the hot water heater.
And this.
That's a pressure relief
Oh.
valve.
Okay.
That's you know, all hot water heaters have that.
Oh yeah. Okay.
I was doing something, and so I left this off. It should be like that. Come on. Being difficult. Come on, you're gonna get your picture taken. All hands world.
Nice.
Yeah, I've been pleased with it. You know, it's
And this
worked
is
very well.
just your extra hot water if you need it,
It's just, yeah, it's extra,
or just
Intake.
supply.
yeah,
Oh,
extra
okay.
supply for whatever, you know, if I want to put in, like you said, another hot water heater for domestic use or to augment this one or whatever.
You built like a little slab for it.
Yeah. Big pedestal.
And then this is the start of the polyurethane or PEX.
Yeah, PEX. Polyethylene crosslink. Whatever that's what the X stands for.
And it goes all throughout here, and then
Right. It's in the entire basement, on the whole slab.
so underneath the walls too.
Pardon?
Like underneath the wall too, or
It
Or-
doesn't go underneath the footing here. no.
okay,
It's just in the flat work.
yeah.
And in here, you know,
Yeah.
it's underneath these walls,
Oh, okay.
but it's not underneath any footing. See, there's a footing there because that's a bearing wall. That bears the half span of the floor.
You poured the footing and just built it up with a 2x4 or something.
My footings are
6-inch floor.
no, No, the code calls for 12-inch, I think, but I made mine 18. I wanted it
Oh,
wider.
wow.
And then I think that, I think it's a 5.5 inch, because I think I've got a 2x6 bearing wall.
Oh, nice.
Yeah.
So the footing goes from here to the end of that one right there?
Well, it's equal distance on the outside of the,
Oh, on the other side of this.
yeah.
Oh. So there's another 6 inches of concrete over here?
Yeah.
Oh, wow. Dang, that's a lot of concrete
Yeah, a lot of concrete.
mix.
I wasn't sure about building on the sand, but I actually think that it's probably a better strata, a better surface to build on than anything.
Yeah, I like how it looks.
And honeycombing, it was before I got the vibrator.
Oh, yeah.
Yeah, look at this. Water through that loop, but it's it's a more sophisticated device. It's got a thermostat on it that opens and closes the valve depending on the temperature that you're setting it at. And it maintains that as long as it can, I mean, it can't put out 90-degree water if your tank is only at 85 degrees, of course, but as long as it's got head on it, as long as there's more temperature in the vessel than in the loop, then you're good.
And that helps with your return heat also? The hotter you can get it, kind of?
Well, I don't know if it actually affects your return or not.
Because you said you heated the water tank up to 140 or something, and
I
then
think that's about what I was seeing.
and then you pumped it out at 85 or 76.
Something like that.
Yeah, and then back at 72.
72, something like that, yeah.
And you can choose what temperature you send it out at, right? Yeah.
Right. And you can set the heating elements in the tank so that you can regulate the temperature in the tank itself. And set the tank static, so that nothing's running in the loop. You're just heating the
Tank.
wastewater.
Yeah.
And then start up the pump and watch what's happening in your loop. I got a temperature, a thermometer on each side, on the output side and on the return side, and then another one, temperature and pressure on the tank itself, so you can take a look at what you got. Again, you can't send your water out higher than what your tank will do. So you want to keep the water in the tank a little bit hotter, 10 degrees or so, than what you're trying to, than what you want your
Yeah.
base temperature in your loop to be.
Sure is sunny out.
Called grizzly screen. Have you ever? It's like a 4-inch mesh, and it's made with like a 10 gauge or an 8 gauge wire. It's heavy, and it's usually sold in an 8x8 square.
I think I've heard of it, yeah.
Yeah. Well, anyway, I did that, and I tied the tube to the screen so it made I could get a pattern and hold it. And then I made little spacers so that I could hold it up off of the ground or off of the grade, 2 inches, and then put 2 inches on top of it as well. So, you know, there's a little, I did a
Oh,
little,
wow.
I want to think about it a little more. And I hadn't thought about that grizzly screen. I haven't thought about the whole thing for a long time.
How thick is the floor?
4 inches.
Okay.
You know, a 2x4 is 1.5 by 3.5. Okay, so I said 4 inches, I mean 4 inches.
Okay.
Yeah, full 4 inches.
And the piping, is it directly in the middle, or
Yeah, pretty
Okay.
much.
so there's some concrete underneath the piping as well?
Yeah, I tried to get the pipe right in the middle.
Nice.
Yeah. Yeah, I told you that they say that if your output temperature is within 10 degrees of your return temperature, or more accurately, if the return is within 10 of the output, you've got an efficient system. And mine was coming back about 4 degrees.
Oh, wow.
Yeah. At first, I just let the thing run 24/7. Oh man, it was nice. But it was also kind of expensive.
How much more expensive? Like
No.
double the price, or
No,
like $100 more?
maybe 50.
Oh, okay.
But you know, when I calculated how much more it was going to cost me to do it with electricity than natural gas, I made a mistake, and it is more expensive with electricity, no question. However, like AEP offers
Off-peak.
off-peak.
You were telling me about
Okay,
that,
okay,
yeah.
okay. And so I think, you know, if you had a big container or a couple of 50s or a couple of, you know,
Like a water heaters?
Yeah.
Okay, yeah.
a couple of hundreds or, you know, some
Yeah,
capacity.
you talked about getting an additional one or something?
That's what I would do, yeah.
Yeah.
You know, if one had the capital to work with to develop these things, yeah, I think that'd be the way to go. If you could buy the energy off-peak, you know, I don't know if it needs a separate meter or what the deal is, but if you could do that so that you're heating, you know, you're just heating the water off
Yeah.
and run your pump at the same time so that you're circulating the heat in your floor, and then when the off-peak time runs out, hopefully you've got enough stored, you know.
To make it through the...
Yeah. Because if your tank is 140 degrees, I think I was setting my water out at it. I think the most I ever set it out at was 85, but that was too much. I cut back. I think I'm at about 78 or 80 now.
And then it returns about 4 degrees.
Yeah, 76, 72, somewhere in there.
Wow. So yeah, you are holding a lot of that heat.
Yeah.
Yeah.
Yeah, because of the mass of all that concrete, you know, and then everything down there is that temperature, so it has a tendency to stabilize things. When I was doing my sit-ups this morning, I noticed how cold my weight is. You know, my 10-pound weight is a cast iron weight. You know, I remembered, gee, it never used to be this cold. And that it's a good, you know, it's like everything. I don't know how to explain it. Everything in the place holds that temperature.
Yeah.
And I really forgot about heating with wood. I haven't done that for so long. When you sold wood to this guy, does he have a fireplace, or
Yeah.
is that what most people?
Yeah.
There's probably very few wood furnaces, huh?
No, maybe a couple.
You know of a
yeah.
couple?
Yeah. Like a wood stove. Yeah.
Well, you know, at one time there were actual furnaces with a
Oh, you mean in the basement or something?
with a
Yeah.
combustion chamber and then the fan and exchange. You know,
Wow.
a forced air system, except it uses wood instead of natural gas for the heat source.
Yeah, this woman that we deliver wood to says she has a fireplace in the basement, but
Oh wow!
yeah, I don't know if that's the same.
Huh?
It might be what you're talking about. She's just calling it a fireplace.
Maybe. I thought, you know, like a wood heater in the basement, that'd be cool.
Yeah, I agree. I've seen that before, and they just go to like the egress window and throw the wood down that way.
Sure,
Yeah,
sure.
and you could maybe do that. Have you ever thought about that?
Yeah, I've got a hole in the floor right over there where I was going to put the natural gas unit out, and I think that hole still exists. You know, I've covered it, but structurally, I've still got an exit.
Oh, you mean like moving the stove downstairs? It's in the corner right there, right?
Yeah.
And then go straight up,
Straight
and
up.
then over to that hole.
Well, I think there's another hole back there. It's just
Oh.
I covered it because I did have a pipe going through. I may have offset it to there. I don't remember. Now, if I damp it down for like 10 minutes or 5 minutes just to get it hot and then give it a little oxygen, oh man, it goes right off.
That's what you're gonna do.
Yeah, that's what I usually do.
Yeah.
It's probably hot enough now that it fire right off. But I usually let it, you know, heat up a little bit.
Yeah, there it's trying to go.
Right. The extra air is actually blowing it out. You know, it's cooling it off a little bit, essentially. It's like when, you know, I put the fan on there, that cools the external part of the stove off, which helps damp it down a little bit. When it's hotter than heck, everything wants to go up the flue there as quickly as it can.